video, I will be discussing the MFP 3D software, particularly the master panel GUIs and the sum and deflection meters. I will also introduce some important concepts on imaging and the AC mode. First, let's look at the sum and deflection meter. The sum and deflection meter window are useful while completing alignment of the light source on the cantilever. The meter shows the real-time status of the critical optical detector parameters. The sum is the total amount of light collected by the photo detector in volts. This parameter is useful for telling how well the light source is aligned on the cantilever. As part of the calibration process, align the laser spot as described in the last video by moving it at the end of the cantilever. Once, at the end of the lever, maximize the sum voltage with the LDY thumb heel. Next is the deflection meter. We covered this topic in the previous video. One takeaway from the video is that, before we start imaging, since the cantilever is still relatively far away from the surface of the sample or undeflected, the deflection should be 0. So 0 the PD by following the procedures outlined in the previous video. The amp is the amplitude of the cantilever. The drive amplitude in the master panel controls this value. The drive amplitude is the voltage applied to the shake piezo in the cantilever holder to obtain the amplitude seen in S&D meter. Usefully in AC mode only. Increasing or decreasing this value has a corresponding effect on the cantilever amplitude monitored on the S&D meter. Please note that the value of the drive amplitude in the master panel is not necessarily the same as that of the S&D meter. So to get the cantilever to oscillate at a chosen amplitude, increase the value of the drive amplitude with the provided knob while monitoring the S&D meter. You can also input the value with a keyboard or use the arrows located around the field. The next parameter on the S&D monitor is the phase. The phase is simply the time lag, or LED, between the response and the drive sine waves, expressed in angular units, degrees or radians. This animation explains the concept of phase. In diagram A, the cantilever and the driver are out of phase while in B both elements are in phase. At resonance, the driver and cantilever are 90 degrees out of phase with each other. On the other hand, below resonance, the driver and cantilever are in phase. In the lens group, we usually oscillate the cantilever at resonance, so before imaging, we adjust this value in the S&D meters if necessary. To change this value, navigate to the Tune tab on the master panel and vary the phase lag value as appropriate. Next, we look at the master panel. We will just examine the relevant parameter for imaging in the AC mode. The scan size is the choice of an area we intend to image. The scan rate is the rate of the scan in Hertz. This parameter is a more important factor than the scan speed when imaging. The scan speed is the speed that the cantilever tip is moving across the surface. So given the same scan rate, the scan speed increases when you are scanning a relatively large sample area. Scanning at high speed can result in low image resolution. A crucial parameter on the master panel is the set point. The set point is the amplitude value that the Z feedback loop will maintain as it scans the surface under the tip. This animation explains how the set point and the Z feedback loop works together while imaging. So for a given set point, this means that the Z feedback loop will move the piezo towards the surface until the amplitude is damped by the surface, to the value of the set point. This new amplitude is constant until there is a change in topography. In this region, notice the damped amplitude due to the change in the sample height. The amplitude is less than the set point, and the Z feedback loop moves the piezo away from the surface until the set point amplitude is reached. In the last region, the amplitude has increased more than the set point. Because of the topography of the sample, similarly, the Z feedback loop moves towards the sample to maintain the set point. Another important parameter on the panel is the drive frequency. The drive frequency is the frequency at which the cantilever piezo is driven. In the lens group, we set this value to the natural frequency of the cantilever. We calculate the natural frequency from the thermal test. I will demonstrate this procedure in the next video. In the next topic, I will conclude the calibration procedures and show you how to image in the AC mode.